Everybody. So in the previous video, we simulated an RL circuit switching on and off, or we focused on when it switches off, the natural response. So now let's give an RC circuit a try. It's going to be just like the RL circuit, same procedure. So let me just put something together. So I'm going to put a capacitor somewhere, and then a resistor. Let me zoom in here so it's bigger. Okay. And rather than putting a switch like this, that's like what it looks like in the book, right? Where you can turn the switch on or off. But not for the simulation. For a simulation, let's use a square wave. So that's here, clock. And I think last time I used the current, right? Let's use voltage this time. And again, you can always do source transformations, right? You can have a current source in parallel with a resistor, or a voltage source in series with that same resistor. Okay, so let me just tie all these together. Okay, and for the simulation, I better set my ground. All right, here we go. And this last time we were measuring current, this time let's measure voltage. So the voltage here, that's going to be the voltage straight out of our source. So why don't we show this first? Okay. And why don't I slow this down? So just to make the numbers easier, I'll make this 1 volt and the frequency 1 hertz, right? So it's 1 volt. And if you go over here on the right side of the screen, let me move my head. There we go. Okay. All right. So here we got 1 volt at 1 hertz, and it's 50% on, 50% off. Okay. And then under document, these are the settings for the simulation itself. So let's say I want to run the simulation for 5 seconds. Here we go. All right, then it's kind of what I expected. Let me turn these cursors off, right? So it's running a period of 1 second because it's 1 hertz, so 1 cycle per second. And I'm running the simulation for 5 seconds. Okay, so now let's measure the voltage across the capacitor. Where is it here? Here. Well, this is technically measuring the voltage across the resistor. So I should switch these around, actually. So I'm just going to trade places here. Okay. All right. So now this blue one will be technically the voltage from the ground to over here. So the voltage across the capacitor. Okay, and then let me run that. And not super exciting. Let me change the values here. So let's say 1 microfarad, and let's make it something different. 1 milli, which is like huge. And then let's make this less. Okay. Let's see. Let's adjust these just so it makes for a nicer picture. Okay. All right, let me move this. Here on my graph, I would like to zoom in so I get a better picture here. So if I click somewhere in the graph, and then here under item, these are the properties of the graph itself. So in the x direction, let's say I go from 499 milliseconds to 1 second. Right, so I just zoomed in here. Let's zoom in a little bit more, so maybe 600 milliseconds. Okay, let's zoom in a little bit more. So 55.55. 550. Okay. Just so you have a bigger view, right? So you can really see the exponential decay of the voltage across the capacitor. Now let's say I wanted to measure the time constant. So that's here, and I click somewhere in the graph, and then under item, here are the cursors. I'm going to pick track. So that's the one that measures X and Y. And I want to measure across the capacitor, which is probe 2, the blue one. So over here, I'm going to switch this over to probe 2. I'll switch cursor 2 over to probe 2. So you see how these turn from green to blue. And I want to measure from right here where the switch opens to where the voltage drops to 30%, 37% of its original. So if you look down here, I'm aiming for something around 370 millivolts. So there, 367, that's close. Okay, so, and then right here, what's the time constant? 10.055 milliseconds, so 10 millisecond time constant. If I change these values a little bit, let's say there. Okay, and then let me zoom my graph again. So let's say from 490 milliseconds to 550 milliseconds. Right, now let me move my cursors around. So my cursor is where it starts, and then this second cursor right to where I see about 368 there. Right, so now let's look at the time constant. 20 milliseconds right here. 20 milliseconds. Okay, so hopefully not too bad. So just keep on practicing. Let me know if you have questions, and then I'll see you on the next video.